periodic table has been around hundreds of years, and it has been revised by important scientists like these people here.
Lavoisier was the first scientist to write a list of elements. It contained 33 in total. He also defined an element as any substance which could not be decomposed into any simpler substances. He then classified these known elements into 4 groups: elastic fluids, nonmetals, metals, and earths.
J.W. Dobereiner created triads of elements that were similar to each other. He found that the atomic mass of the element in the middle of the triad was close to the average atomic mass. His findings helped other scientists have a clue as to why atomic mass might play a role in arranging the elements.
John Newlands arranged the elements in order of relative atomic mass. In doing this, he found that the elements 8 spaces apart were similar to each other. However, in his table, he had elements that were metals and elements that were nonmetals grouped together, so other scientists didn't approve of his table. He was the first to assign atomic numbers to elements.
In 1864, Meyer had produced a table of just 28 elements, which he listed by their valence electrons. His main contribution was his recognition of periodic behavior, a repeating pattern of a property shown on a graph.
Mendeleev released a periodic table and arranged the elements known at the time in the order of relative atomic mass. This periodic table allowed for scientists to progress on from his base periodic table.
Henry Moseley developed the application of X-ray spectra to study atomic structure. In 1913, Henry published the results of his measurements of the wavelengths of the X-ray spectral lines of a number of elements. This showed that atomic weight was not the significant player in the periodic law, and this helped with the modern periodic table and how it is based on the atomic numbers of the elements. The periodic law is when the elements are arranged in order of increasing atomic number. There occurs a periodic repetition of physical and chemical properties. On the periodic table, there are a number of groups that share similar qualities with each other. The groups on the periodic table go down the column, and the periods go left to right. Some of the groups that are within the periodic table are representative elements. The groups or families can be further categorized into the representative elements and the transition metals. The representative elements are those elements within the first 2 families or groups, 1 and 2 on the far left, and the last 6 families or groups on the right of the periodic table. The transition metals are the elements in those groups within the middle of the table. The transition elements are any of the set of metallic elements occupying a central block, groups 4 through 12 in the periodic table. Chemically, they show variable valence and a strong tendency to form coordination compounds, and many of their compounds are colored. Metals are elements that form cations when compounds of it are in a solution, and oxides of the elements form hydroxides rather than acids in water. Most metals are conductors of electricity, have crystalline solids with a metallic luster, and have a high chemical reactivity. Apart from hydrogen, nonmetals are located in the p block. Helium, although an s block element, is normally placed above neon in the p block on account of its noble gas properties. In chemistry, a nonmetal is a chemical element that mostly lacks metallic attributes. Metalloids are elements that have both metallic and nonmetallic properties, such as arsenic or boron, a nonmetal that in combination with a metal can form an alloy. In the periodic table of elements, elements are arranged in a series of rows so that those with similar properties appear in a column. In chemistry, a group, also known as a family, is a column of elements in the periodic table. There are 18 numbered groups in the periodic table, but the F block columns between groups 2 and 3 are not numbered. Alkali metals are chemical elements found in group 1 of the periodic table. The alkali metals include lithium, sodium, potassium, rubidium, cesium, and francium. The alkaline earth metals are 6 chemical elements in column 2 of the periodic table. They include beryllium, magnesium, calcium, strontium, barium, and radium. Transition metals are any element in the D block of the periodic table, which include groups 3 through 12 on the periodic table. The intertransition metals are the 30 elements of the lanthanides and actinides series, which are the subseries of the transition metals. Halogens are a group in the periodic table consisting of 5 chemically related elements: fluorine, chlorine, bromine, iodine, and astatine,
and the artificially created element 117. Noble gases are any of the 7 chemical elements that make up group 18 of the periodic table. The elements are helium, neon, argon, krypton, xenon, and radon. These elements cannot react with any other elements because they have a complete outer shell.
Okay, for the electron configuration, for example, let's say carbon, and the first thing would be 1s2 because what you would do is you would look at the number, which is 1, and then the orbital, which is s, which is s2 because that's how many electrons you can fit. So then you would go to the next orbital, which would be 2s2, and then finally to get to carbon, it would be 2p2. Okay, to find the valence electrons, you would look for the highest orbital number, which would be 2, and then you would count how many of the electrons are in it. So there would be 2 in the 2s2, and then 2 in the 2p2. So 2 plus 2 would equal 4. So that's how many electrons, or valence electrons, carbon has in its atom. Okay, so how to do the electron dot structure? What you would do is you would do the atomic symbol, which is C, and then how many electrons it had, or valence electrons it had. So for carbon, it would be 4, and all you would do is place them around the side. So it would be 1, 2, 3, and then 4.
On the periodic table, trends can be found based on physical and atomic properties of elements. Here are a couple examples of trends on the periodic table. Atomic radius is 1/2 of the distance between the nuclei of 2 atoms, just like a radius is half the diameter of a circle. Atomic radius increases as you go down a group, and it increases as you go left on a period.
Ionic radius is the radius of an atom's ion. As you go right to left in the periods, then it increases, but if you go down the groups, it increases.
Ionization energy is the energy required to remove an electron from a neutral atom in a gaseous phase. Ionization energy increases as you go left to right on a period, and it increases as you go up on a group. Electronegativity is how strongly an element will attract an electron. Electronegativity increases as you move left to right on a period and decreases as you go down a group.
The metallic character of an element can be defined as how readily an atom can lose an electron. From left to right across a period, metallic character increases because of the attraction between valence electrons, and the nucleus is weaker, enabling an easier loss of electrons. As you move left across the periods and down the groups, there is an increase in the metallic character. And as you move right across the periods and up the groups, there's a decrease in metallic character.